Good morning. Today we're going to talk about section 2.4, writing equations of lines. You'll recall EQNS is going to be my abbreviation for equations in this course. Alright, before we get to the task at hand, I want to evolve a particular way to write equations of lines in a particular form. Alright, to that end, let's say we've got an XY plane. And let's say we've got some non-vertical line that intersects the y-axis somewhere. And I'm just going to draw a generic non-vertical line. And let's say the y-intercept is 0, b. Right? So b is going to be the y-intercept. And I'm going to pick some other point on the line. Any point, and I'm going to keep it variable, so I'm just going to label it as xy, meaning the x and y coordinates of any other point on this line. Alright, I can compute the slope of this line with these given coordinates. It's going to be y minus b, remember b is the y coordinate of the y-intercept, over the corresponding change in x is going to be x minus 0. 0 because 0 is the x-coordinate of the y-intercept. Alright, what I can do here is simplify this expression for slope a little bit. Of course, downstairs, x minus 0 simplifies to x. And I'm going to take this equation and I'm going to solve for y. I'll multiply both sides by x. So mx equals y minus b. And then I'm going to add b to both sides to ultimately solve for y. So what I have really done is write the equation of this non-vertical line, understanding that the slope is m, and x and y can be any other point on this line. Well, let me write it. Mx plus b equals y. I can rewrite this as y equals mx plus b, and I'm sure that you'll recognize this y equals mx plus b format. This is an equation of a line in slope-intercept form. Of a line, slope-intercept form of a line equation. Slope-intercept form because you can easily see by inspection the slope and the y-intercept if your line is in the form y equals mx plus b. Very powerful and certainly the most used form of line equations used today. Okay? Very powerful form. For example, we can say find the slope of a given line. Let's say 2x, minus 3y equals 6, for example. Now, without this tool, to find the slope of this line, we'd have to make a table of values, establish a couple points on the line, plug in the coordinates of that point to the slope formula, and grind out the slope through that process. Well, this form, y equals mx plus b, makes it a little bit easier, actually quite a bit easier. All I need to do is convert this form to the form y equals mx plus b, and then I'll be able to read off the slope as my x coefficient or my x multiplier. Alright, so I'll take this equation 2x minus 3y equals 6 and basically do algebra type things to both sides of the equation. First I'll subtract 2x from both sides. Then I'll divide all terms, both sides, by minus 3. The minus 3's cancel on the left, of course, and I'll get y equals minus 2 over minus 3 reduces to 2/3. So that term reduces to 2/3 x plus, of course, a minus 2. So if I want the slope of this line, by converting to this format, I can then see the slope is nothing more than my x multiplier in this form. My slope is 2/3. Very much easier to use this very powerful slope-intercept form. Oh, by the way, the y-intercept is, of course, -2. Alright, so let's expand this idea. And the title of the section is, again, Writing Equations of Lines. So you'll be getting very familiar with this expression. Write equation of line with slope equal to -1/2 and y-intercept equal to +7. Well, this is a breeze now, because you're given the slope, you're given the y-intercept, and all you've got to do in slope-intercept form is substitute in the slope and substitute in the y-intercept, and you're done. Almost couldn't be easier. Alright, let's go up the ladder and try to tackle something a little harder. Write equation of line with slope equal to 4 and through a known point, 5, 9. Well, we know the slope. Slope's 4, but we don't know the y-intercept. We are given some other point besides the y-intercept. Oh, please note, if this was the y-intercept, the x-coordinate would be 0, not 5. Alright, so we know that is not the y-intercept. Well, what are we going to do to find it? Well, I can start like this. I can say I know the slope, so I can plug in m for the slope in my slope-intercept form and leave my b value, my y-intercept, as unknown. Now, because this point is on the line, we know it must solve this equation. So what I'm going to do is substitute the values of 5 and 9 for x and y respectively, and then I can solve quite easily for the y-intercept. So 9 equals 4 times 5 plus b, so 9 equals 20 plus b. b is going to be 9 minus 20, and of course that's -11. Alright, so don't stop here. Your final answer is to write the equation of the line, so your final answer will look like this: y equals 4x minus 11. And in problems in this section, we're going to assume that we are giving our answers in slope-intercept form. Okay. Another one. Write equation of line. Remember, that's the title of this section, writing equations of lines. Write equation of line with a slope of -2/3 and through a known point. Similar to the last problem, but a little more difficult. Again, this is not the y-intercept. If this point was the y-intercept, the x-coordinate would be 0. So I can say for sure the slope is -2/3, but I don't know the y-intercept. So again, we will plug in the coordinates of 5 for y and -4 for x, and use those to solve for the unknown y-intercept. Now be careful, we're going to have to deal with some fractions here. 5 equals -2/3 times -4, that's +8/3, plus b. If I subtract 8/3 from both sides, I can solve for b. I'm going to have to get a common denominator here. 5, of course, is 5 over 1. If I multiply top and bottom of 5 over 1 by 3, I get 15/3. And of course, 15/3 minus 8/3 is 7/3. So b is positive 7/3. So my final answer is going to be y equals minus 2/3 x plus 7/3. Okay, let me put a box around the circle around this. This is my final answer for that problem. Go on to the next one. Alright, this one's a little harder still. Right, equation of line through minus 5, comma 4, and 8, comma minus 6. Alright, now this one's quite a bit different from the first ones we've done. We are not given the slope, and we are not given the y-intercept. What are we going to do? Well, of course, you can always compute the slope of a non-vertical line given 2 points or coordinates of 2 points on the line. So first I will compute the slope of this line through my slope formula, y2 minus y1 over x2 minus x1. So I get a slope of minus 10 over 13. Alright, a fractional slope. We're going to have to deal with that. So my equation is going to look like this in the end. But again, I don't know the y-intercept, at least not yet. And just like we did before, we can pick coordinates of any point and plug them into this line, since we know that both these points must be on the line. Alright, I don't see any clear advantage to picking one over the other. I'm going to pick, let's see, let's say y is 4 when x is minus 5. And we're going to have to do some fraction arithmetic here to solve for b. 4 on the left, well, minus 10 thirteenths times minus 5 is going to give me a positive 50 thirteenths. Running out of room here. Let me go over here. I will subtract 50 thirteenths from both sides. And then perform a little fraction arithmetic. Well, 4 is, of course, 4 over 1. If I multiply top and bottom by 13 here, I'll get a common denominator of 13. I get 52 over 13 then, minus 50 over 13 equals b. And now that I've got common denominators, I can subtract the numerators as indicated. I get 52 minus 50 is 2 over 13. So my unknown y-intercept is 2 thirteenths. But again, you're not done yet. Your final answer will look like this. Remember, it's got to be a line equation. Y equals minus 10 thirteenths x plus 2 thirteenths. This is your final answer to that given problem. Okay. All right, fresh screen. All right. Right. Equation of line through minus 2, 5 and parallel to this line. Alright, so they're getting a little harder still. We're not given a slope, we're not given a y-intercept, we're not even given 2 points, but we are given 1 point, and the knowledge that the line we need has to be parallel to this line. Alright, well, I can easily find the slope of the given line. If I convert this to slope-intercept form, I'm going to subtract 3 from both sides, and I'm going to say y equals 8x minus 3. Let me read this instead of right to left, left to right. I'm going to say y equals 8x minus 3. Alright, converting this line into slope-intercept form. I can then easily see the slope of this line is 8. Once you're in slope-intercept form, you can read off the slope as your x coefficient. Alright, so this line that we need must be parallel to this line. Well, so I must have the same slope. So I need a slope of 8 to answer my question. Alright? So I know my final answer is going to look something like this, y equals 8x plus b, but I don't know the y-intercept. And of course, what I'm going to do now is plug in the coordinates of a known point. When y is 5, x is minus 2. I can solve for the unknown y-intercept pretty easily. 5 equals minus 16 plus b. Plus b. B is, of course, then 21. So my final answer is y equals 8x plus 21. Okay. Oh, let's try a real nasty one. Write equation of line through 2/3, 1/4 and perpendicular to y equals 3x minus 2. Alright, I'm given neither a slope nor a y-intercept, but I am given coordinates of a known point through the line. But the problem is they're fractional coordinates, and we like to stay away from fractional coordinates when we can. Well, here we can't. We're forced to deal with them. Further, we're not given the slope of the line that we need, but we do know this line has to be perpendicular to a given line. Well, what I can say is this line that they've given us is already in slope-intercept form, and we know quite easily that the slope is 3. Because our needed line is perpendicular, the slope must be a negative reciprocal, and the negative reciprocal of 3 is minus 1/3. Okay? Alright, so with that detective work done, I can say my needed line is going to look like this. It has to have a slope of minus 1/3. And again, the y-intercept is unknown. Well, what I'm going to do, just like in the previous two examples, I'm going to plug in the coordinates of a known point, and unfortunately, they are fractions. Yeah, that's okay. It forces us to do a little fraction arithmetic practice, right? So I'm going to use this equation now to solve for b. I've got 1/4 on the left, Minus 1/3 times 2/3, no cross canceling, so I'm going to have to multiply across. Minus 2 over 9 plus b, doesn't look too bad now. I'll then add 2/9 to both sides to solve for b. Well, I'll need a common denominator. 9 and 4, the least common multiple of 9 and 4, I think, is 36. So I'm going to have to multiply top and bottom here by 9. I get 9/36. And here I'm going to have to multiply top and bottom, of course, by 4. And I'll get 8/36 equivalently. Now that I've got a common denominator, I can add the numerators as indicated and keep that common denominator. So then my final answer is going to be y equals minus 1/3 x plus 17/36. The slope is minus 1/3, and the y-intercept turned out to be 17/36. All right, let me point out one more. Right? Equation of line through minus 2 minus 5 and perpendicular to the line x equals minus 2. Now here's another one where students might waste a lot of time punching buttons on their calculator, getting frustrated, when really a moment's reflection should be able to tell you the answer. Alright, we are given neither the slope nor the y-intercept of the line we need. But we do know a given point, and we do know it's perpendicular to this line. Do you notice anything about this line here? Well, it's a vertical line, is it not? X equals constant, vertical line. And if you're perpendicular to a vertical line, that means you need a horizontal line. For my final answer. Now, horizontal lines are always of the form, horizontal lines are always of the form x, I did it again. Maybe it's good I made that mistake. Students sometimes make that mistake too. Horizontal lines are always of the form y equals constant. Y equals constant, horizontal line. So, if I need a horizontal line through minus 2, 5, well, I'm going to have a constant value of minus 5, right? In a horizontal line, y never changes. All right, so y equals constant. What is that constant got to be? Here, it's y equals minus 5. Alright, so we're done. Really no algebra needed, just an understanding of the concepts. This is my horizontal line perpendicular to x equals minus 2 through the point minus 2, minus 5. Okay? Alright, we're at the 24-minute point. We'll call it a day. This concludes section 2.4, writing equations of lines.